Hi, everybody. I'm going to go through a short script and set it up so that you can do a little job, which is explain the graph, the ggplot, fairly complex ggplot that's at the end of the script. So for this script, we'll be reading in text data of all the novels of the English writer Jane Austen, who wrote five novels back in the early 1800s. And so the first thing that we'll do is, as usual with the script, we'll clear the environment. Then I've already installed these packages. You will have to install them. So I'm going to load them. First load tidyverse, then load the package scales, load the package some color packages, load the tidy text package, load the Jane Austen R package, and load the package RVest. Now, I'm going to use the command Austen underscore books that's in the Jane Austen package to create an object called Austen. And we now see that Austen is here in the environment. It's a little data frame with 73,000 rows. Each row, if we click here, each row is going to be some text, a line of text from the book. So you could start reading. The family of Dashwood had long been settled in Sussex. Their estate was large and their residence was at Norland Park. If you like Sense and Sensibility, the book this is from, you can read it here for free. You can watch the movie, or you can check it out from the library, which is what I would recommend. It's a great novel. After Sense and Sensibility, we have Pride and Prejudice. After Pride and Prejudice, we have Mansfield Park. After Mansfield Park, we have Emma. And finally, we have Northanger Abbey. And I think those are oh, we have Persuasion. So six actually in this. I think that's, yeah, six books. So that's the data that we have. This text field, we just have lines of text. So what we're going to do is we're going to take these lines of text and turn them into what are called bigrams. So we're going to turn them into every two-word combination. This code is going to do that. I don't think you need to know too much about what this code does, except let's look and see what it does when here we go. We have the bigrams separated, and we have every pair of words now here. So we look at this. We have, if we start, the family of Dashwood had long been settled. But notice everything's twice because everything's a bigram. Every word is with the word before it and with the word after it, because the word before it and the word after it give context to that word. And that's a little bit of what we're going to explore in this script today. So what we're going to do is we're going to use a standard sentiment data set, just a very basic one, called AFIN. So let's run this. And it requires the text data package. So I guess I didn't have that installed. So I'm going to install the text data package. And now I have it, so I'll run the AFIN command, and it prompts me yes or no. So I'm going to say yes here, putting a 1 down there and hitting yes. Now it's downloading now what we see with AFIN is a whole bunch of words, some with positive value, valence, and some with negative value. And trigger alert, some of the words are ugly words. And you may not want to look at all the words in this list, 2,477 words. English has 1 million words, so this is just a tiny set of very common words and their valences as determined by some group. You can write your own list. Sit down and write down a list of 50,000 words and scale them on a positive or negative scale according to how good they are versus bad they are, how happy they make you feel, how sad they make you feel, right? Whatever scale you like. Again, we're not doing real science here. We're just showing how to do the coding. So we sentiment that. Now, sometimes words are preceded by not, no, and never, and without. So if somebody is not happy, that that has the word happy in it, but that we shouldn't score that high, right? We should score that low. Not happy would mean sad. So the valence of that word would be the negative of whatever valence happy is. So we're going to want to track these negation words. We'll just do four of them here. And now we'll take these uh, separated bigrams. We'll see if one of the words is in these four negation words. Then, if it is preceded by not, no, never, not, then we will merge with the sentiment data, and then we'll just count up how many of these words there are. So when we run this, we see that there are 503 words that have not, no, never, and without before them, and then the word doubt, for example, appears 96 times with a no before it, and doubt has a valence of -1. The word like has a valence of 2. It appears 95 times, and with a not like, not help. So you get the idea here of what these negated words are. Why are we doing this? Just again, proof of concept coding, see how it works. We're going to clean this up a little bit and just have the top 10 of these words. That'll be a data set we'll call PD. So here we have PD. It's the same word one, and then what the second word is, the value of the second word. And we'll have its value times n. We'll call that the contribution, and then we'll sort them according to their contribution. And we have first never, then no, then not, and then without. And then we'll have our ggplot. And look at this, what we have here. This amazing plot. Again, the meaning isn't really the important thing here. We have a bunch of words that are preceded by never, a bunch of words that are preceded by no, a bunch of words that are preceded by not, and a bunch of words that are preceded by without. And we then have a bar that's its sentiment score, this sort of overall score, the sentiment times the number of occurrences. And you might think that's interesting. You might think it's not interesting. Your job is to look at this ggplot and explain this code. So we see it's a bar plot, but what's all this other stuff doing? What's facet wrap doing? What's this doing? What's this doing? What's this doing? What's this doing? So there's about 10 choices here in the ggplot. Your job is to figure them out and explain them. You can do that by saying, oh, what if I leave one of them out and run the command with everything else? How does that change things? You can look up these comments on using the web. You can look up ggplot tutorials and figure this out. You can look at Kieran Healy's book. So your job is to figure out what this ggplot graph is doing.